Welcome back to this series whereby we'll do a recap of a chapter in under 30 minutes. All you need is just a piece of paper and a pen and write along with me. Today, we will talk about Form 4 Chapter 5, which is waves. Okay, so guys, wave is actually a chapter whereby it is almost close to 85% theory, so it is suitable and recommended for people who do not like calculation, unlike Form 4 Chapter 3. Gravity. Now, so let's start waves. So usually in waves, the most important thing that you have to know is what's the difference between a transverse wave and longitudinal wave. So of course, it depends on how your molecules oscillate. So in your transverse wave, you will realize that as the direction of propagation is to the right hand side, meaning to say that your particles will travel to the right hand side, your wave will travel to the right hand side. So you will realize that your particles actually oscillates vertically. This is known as the direction of the oscillation of the particles. So what we are trying to say, if I were to compare this to a wave that you can imagine, is like water. So as water waves try to move to the right hand side, the wave profile goes right hand side. You will imagine if I have a red color ball on the wave, so this ball will end up moving up and down along the wave. So therefore this is transverse wave, where the direction of oscillation is perpendicular to the direction of propagation. What about longitudinal wave? Well, longitudinal wave is the other type of wave whereby again you have your particles, your direction of propagation is to the right hand side, but however in this case your particles oscillate left and right. So this is my direction of oscillation. Okay, now so as the wave travels left and right, your particles will move left and right. So sometimes you will see certain particles will come together where we call this as the compression region. And for the molecules that are alone, we will call them the rarefaction region, which is represented by our sound wave. Alright, so sound wave is the only wave in your syllabus right now. Of course, that includes ultrasound, infrasound, and all the sound waves, which is under the category of longitudinal wave. So in other words, all the other waves that you can name, for example, water wave, light wave, microwave, radio wave, X-ray, they all belong to the transverse wave family. So this is all the other wave. This is only in our syllabus, the sound wave, alright, whereby it oscillates parallel to the direction of propagation. So of course, before we go to the next part, let's talk about what do you need to know in sound waves. So you need to know what is an infrasound. You need to know what is the human audible range. And you also need to know what is ultrasound. So for ultrasound, usually it means that it has higher frequency. So anything more than 20,000 Hertz is considered high frequency. And for sound waves, you also have to remember what is the difference between pitch and loudness. So pitch usually is affected by frequency, and then loudness is affected by amplitude. So you may ask, what is amplitude, right? Okay, so that will lead us to the next part where we talk about the wave properties. So what is frequency? What is amplitude? What is the loudness, affected by? So when we look at waves, we generally look at two different graphs. I repeat, it is two different graphs. So we have a displacement time graph and a similar one. If I don't point it out, you might not tell the difference. It's a displacement distance graph. What about their shape? They will look exactly the same shape, guys. Okay, they will look exactly the same shape. So you cannot tell the difference by just looking at the shape, but you need to check the x-axis. So sometimes this is in seconds, sometimes it will be in milliseconds, microseconds, this can be in cm, or it could be in SI unit, which is meters. Very simple. Okay, so for displacement, this, which is the height of the wave measured from the equilibrium position, is known as amplitude. So that will be the height of the wave. Do not confuse with the name given to the point crest, or don't get confused to the name given at the bottom, which is we call this called trough. So the point is called a crest. The lowest point is called a trough, the highest point is called a crest. The height is amplitude. Of course, this will be known as negative amplitude. So as for the vertical, they are the same. What about the horizontal? If we compare, this is the starting point and this is a complete wave. If this is time taken, this will be known as the period of oscillation. If this is the distance from the start to the end of the wave, this will be known as lambda, which is known as wave length. Correct? So remember, two similar graphs, but they give different information. So what you need to know here is this gives you the t, this gives you the lambda. Now, however, this graph has an additional bonus information. So if you use 1 divided by the time taken in seconds, you will be able to calculate the frequency measured in hertz, Hz. So, and if you combine the frequency here with the wavelength here, you will be able to calculate the velocity, or also known as the speed of the wave, which is the velocity and the wavelength. So this is on your wave basics. Now, if you do not know which definition to memorize for waves, I highly recommend you to read through all the definitions that you can see in this page. For example, what is the definition of transverse wave, longitudinal wave? What is the definition of period of oscillation, amplitude, wavelength, frequency? So these are the things that I highly recommend you to study because the definitions are quite simple and easy to memorize. Now, and short as well. Okay, next. So once we are done with the wave basics, we will lead to the two parts, which is known as resonance versus this thing known as damping. So we have damping versus resonance. Okay, Ken? Alright. Now, so what is resonance? So resonance is actually this thing. So whereby if you hang different lengths of pendulum, you will realize that the two pendulum that has same length, they will have this keyword known as the same natural frequency. So therefore, they will be able to transfer maximum energy, so to allow it to oscillate with the largest amplitude. So there is a knowledge that is going through here, and similarly for another practical application will be if you want to sing, okay, and you want to shatter a glass with your high pitched sound. For example, you want to go like that. Remember, your sound frequency has to be equals to the natural frequency of the glass. You cannot go higher nor lower than the natural frequency of glass. Alright? Now, so that is on our resonance. What about damping, guys? What about damping? So damping is when you have a pendulum, and this pendulum starts to oscillate at a very higher point, but as it oscillates, it will slowly become smaller in amplitude until it stops. Guys, remember, don't say slower, okay? Better word, use it will oscillate with a decreasing amplitude. Does it matter? Same lah, teacher. Slow, decreasing amplitude, sama je. But no, guys, it's a bit different. Because in exam, they might call you to plot a graph to show how damping occurs. So when you plot this, before you even plot the graph, make sure that you label your points equal time interval, because this is going to be t, and make sure that when you draw this, your amplitude decreases consistently, but your time would have to remain the same. So there is a sharp drop in your amplitude, but your time taken for each of the wave has to remain the same. So of course there are going to be theory, like for example, how many types of damping are there, and what causes the energy loss, and what is the energy loss turned into. It has been turned into something called heat energy. So there are many knowledges here. Do practice and make sure that you write your answers out. Okay, so this is a very small section, not capable of essay question yet. Not capable of essay question yet. Now, so we are going to go into the 4 phenomena, whereby the phenomena are reflection of waves. We are going to have refraction of waves. We are going to have diffraction of waves, and obviously we also have interference of waves. So I call this the 4 most important thing in the whole entire chapter. Okay, now, so these 4, each of them has their own potential essay question. For instance, okay, what can reflection ask in their essay question? So reflection, they like to ask, like for example, I want to use a sampan and I want to find the depth of the sea. So this is a very typical question on reflection. Now then after that, for refraction and diffraction, usually they combo together. So they will combine this into an essay question. They'll ask you to build a seaside question, whereby do you want it to build it at the bay or the cape, which the answer is usually the bay. So, and then after that, do you want to build a retaining wall? So imagine if now this is the seawater. Imagine if now this is the seawater and I want to build a very nice resort hotel at the bay. So the bay is curved inwards at this point, and if I want to make sure the bay here is even calmer, I will build a retaining wall, also known as a wave breaker, to protect the bay from strong waves and also to prevent soil erosion. So now what is the purpose of this gap? So as the wave enters, it will spread out. So that is on your diffraction question. Now besides that, there is also a sound refraction question, whereby they also like to ask about the day versus the night. So how would sound travel differently based on day versus night, hot versus cold, so which you can refer to your textbook. Alright, now so as for diffraction, okay guys, as for diffraction, you will realize that they will always ask you about the speaker concept. Like for example, why would someone not able to see the speaker, however the sound can reach the person? So it is not by reflection. It doesn't bounce around. It doesn't bounce around to the person. Rather, it spreads out to the person. So there will be a diffraction concept here. And last but not least, on the interference essay question, they would like to ask about the concert hall question. Like for example, should in a hall setting, should your speakers be further apart? So the answer is yes. You want your speakers to be further apart. So where do you want your So there's a formula in interference which is called lambda equals to ax over d. So we will have a donkey distance here with what is x. X is the distance between your loud sound and your loud sound, distance between consecutive loud sound, and lambda is known as your wavelength. So you need to know these types of questions in which the only way to learn them is through latihan. I can brag and I can talk about all these things, but you will not understand it unless you really start writing on a piece of latihan workbook, which I will link the exercises in the description, and then you will see what you need to do about them. So to do a mini conclusion on the 4 phenomena, first of all, you have to know that the formulas that's related into this chapter is only 2 things. So there's V equals to F lambda. That is something what we call lambda equals to AX over D. But sometimes some people use an additional formula in the reflection whereby the distance is equals to VT over 2. So some of my own students do not use this formula because they feel like to calculate the depth of the sea is just common sense. But if yes, you will see that there's a total of 3 formulas in the whole entire 4 phenomena. Now, what are the things that you have to study? Now, when you learn about phenomena as a whole, you have to pass through this checkpoint first. Number 1, do you know how to draw the phenomena? Let's say, do you know how to draw refraction of wave? Do you know how to draw reflection of wave? Diffraction of wave, in fact, including interference to find your constructive and destructive interference. Now, number 2, do you know how the application works? So as for the application, I've already listed out a few applications here in which you should study, including for reflection. There will be the fetal imaging where you have to scan the fetus in the mother's stomach by using a transducer. So this is under the ultrasound imaging that uses reflection of sound waves. Alright? Now, last but not least, the third thing that you have to know is what changes before and after the phenomena. For example, in diffraction, the most important thing that we know is that the amplitude will decrease. Alright? In refraction, usually it will affect your velocity, your wavelength, and your amplitude will change depending on whether is it a deep region or a shallow region. So guys, please go and find out your answer. This is just a recap, not a teaching full video. Finally, there are a few things that we want to talk about, okay, whereby I will zoom in and talk about interference. So zoom down here. Okay, for interference is usually the hot structured question. So in terms of structure, they like to ask, so what is a constructive interference? Now, so usually constructive interference happens or it occurs when you have 2 wave crests or 2 wave trough colliding with each other. So guys, think from a mathematics point of view, alright? So if you have A and they langgar together to form a bigger wave, how big do you think this wave is going to be? So if you have 1 hand and 1 hand you add together, 2, you get 2 hands. So that's why this will produce 2A with a negative A and a negative A, you will be able to produce a wave which is much deeper, known as negative 2A. So the common misconception here is, guys, negative 2A is a stronger wave or a weaker wave. So remember, in physics, we look at the magnitude. So usually negative A also means it is a stronger wave. It could mean a bright fringe. It could also mean a louder sound as well. So constructive interference, usually you get bigger wave. It happens when you have a crest and a crest or a trough and a trough. But what is the keyword that we need to use here? So we have to make sure that we use this word known as superposition. So rather than saying two waves, a crest and a crest intersect, crest and a crest meet, we say a crest and a crest undergoes superposition. Superposition is the process of adding the amplitudes together. So therefore, that's how you get a constructive interference, also known as a larger wave, where the point is known as the antinode. What about the other type of wave? So we have another one more type known as destructive interference. Guys, so what is destructive interference? Destructive interference is actually known as a node. So it will be the remaining one whereby your crest undergoes a superposition with your trough, whereby you have a wave crest and a wave trough, and these two things will collide and boom, you get a smaller wave. How small? So obviously if this is A, if this is negative A, you will end up with zero amplitude. Why? Because 1 plus negative 1, you get 0. So you will finally end up with a 0 amplitude, which this is usually a weaker wave, and your A2A and negative 2A is a stronger wave. So summarize up, what do they ask in interference? They'll ask you, what is the condition for interference to occur? So as for all the waves, you have to make sure that they are the coherent sources. And as for light only, not only coherent sources, you also know that it has to be monochromatic light. So for more info, refer to your textbook on what is monochromatic light and what are coherent sources. Okay? Now, elaborate on the superposition of interference, you need to know. Now, how for sound waves and light waves, how do I know if this is a constructive or a destructive? So if sound wave, so the constructive interference usually indicates a loud sound. Okay, loud sound. And then the destructive interference usually indicates a weaker sound, or they also say a softer sound. So if they ask you what happens when there's two speakers and I hear a softer sound, that means that destructive interference occurred. Your crest and a trough hit. Superposition. Louder sound, why is that point louder? Because it is a constructive interference. As for light, light has constructive interference when you form what we call a bright fringe, which is a bright line, and it is a destructive interference when you see a dark fringe. Okay, so we have the bright fringe and the dark fringe indicating two different types of interference. So last but not least, on the constructive and destructive interference, you need to remember they are known as antinode and node respectively. Okay, so there are many essay questions we come back to here that you need to practice, so link is at the description below. Finally, we have reached my favorite part in waves, which is what we call as the electromagnetic waves. So in electromagnetic waves, what are the things that you have to study? Okay, guys, it's very simple. So first of all, number one, you need to be able to remember their spectrum. So like radio, micro, infrared, visible light, ultraviolet, X-ray, and gamma ray. So do you remember them? So it will be, Ryan, may I visit your ex-girlfriend? Radio, micro, infrared, visible light, ultraviolet, X-ray, and gamma ray. So in this radio, micro, infrared, visible, ultraviolet, X-ray, and gamma ray, in this series of spectrum, Number two, you have to remember their application. Okay, I will list down a few common ones. Like for example, where do we use radio wave? So radio is usually used in our Wi-Fi signal and also car keys. Alright? So what about micro? It is used in radar, anything that is satellite related. Infrared, usually we use this in the remote control, the red color light. V is visible light, whereby we use this to, I will just write photosynthesis. Okay, what about ultraviolet? Ultraviolet, I will write to sterilize surgical equipment. You can use it to sterilize things, or you can say sterilize water. Okay, and also to detect counterfeit, which is fake money, counterfeit notes. Notes is the paper money. X-ray obviously can be used to do medical imaging, means that you want to scan the tulang, and of course gamma ray is used for the treatment of cancer. Okay, so these are the few common things. I think that you should put your focus on what is radio and what is micro. So when we go towards the right hand side, the frequency greatly increases, causing their energy to go up. Okay, it's just like gamma is more dangerous. So which means that they will be able to have higher penetrating power. That's why gamma ray can pass through your body, can harm your internal organs. But infrared, which is your remote control, will not give you cancer. So it usually means that this thing, due to its high penetrating power, it will be able to travel far. What is the terbalik of this thing? So when we look towards the left hand side, you will realize that the wavelength increases usually means that it will have a greater diffraction effect. So rather than say far, we will say it will spread wider. So diffraction is a process of spreading, okay? So it will spread out wider. So we have the spectrum, we have the application, and last but not least, you need to know what are the characteristics of electromagnetic waves, alright? Before I forget, remember, Wi-Fi, car keys, radar, satellite with drone controls pernah keluar as an essay question in exams, either SPM or even trial papers. So guys, please do make sure you know your facts and application. Now, so what are the characteristics? Now, there are many characteristics of electromagnetic waves. So there are three that I want you to remember. Number one, first of all, the easiest one, they are all transverse wave. I told you, everything else is transverse wave besides sound. Number two, it can propagate. It can propagate through vacuum, also known as it can go through vacuum. It does not require a medium to propagate. Last but not least, you can also say that it travels at what we call the speed of light, which is 3 times 10 to the power of 8 meter per second. Okay, but that's not it yet. In vacuum. So therefore, if you just write all of this out, you will be able to do revision. And if you write this down, you will not need to rewatch the whole video ever again. So take a piece of paper, write this down together. Now, so we have already reached almost the end. I think I've covered the basic 80% that you need in this chapter. It is a very, very long chapter. The only thing that I cannot do everything here are the applications and all the drawing related to the 4 phenomena. So if you really want to do more on the waves, go down to my description. I will link all my exercise videos at the bottom, and I will talk about more on each phenomena in the video below. So thank you everybody. We'll see you in the next video. Thank you very much. Now, if you happen to like this video, please do drop a like and subscribe, so it will help with the algorithm so that I can show this to more students and help more people. So thank you very much.